So we're going to talk today about multiplying and dividing radicals. I have some properties for you to kind of copy down and listen to. But the first one is if I have the nth root of a times the nth root of b. So notice that the indexes are the same here. Then we have the same index and a and b can be multiplied underneath. This is the same thing for dividing as well. A and b can be divided underneath. But the key here is the index must be equal. Okay, they must be the same. So if the indexes are not the same, then there's nothing that can be done with those radicals. Okay, so to combine radicals, we want to make sure we have the same index. All right, so let's look at an example. Let's say I have the square root of 72 x to the third y to the second times the square root of 10 x y to the third. Now we can simplify first, or we can just multiply first. And I actually would prefer that you multiply first and then simplify the radical later, because sometimes the radicals don't simplify nicely until you multiply. So here's what's going to happen. Because the indexes are the same, we're just going to multiply the radical underneath and one big radical. So 72 x to the third 10 x y to the third. So do it in stages. 72 times 10 is 720. X to the third times x would be x to the fourth. Add those exponents together. Y to the second times y to the third would be y to the fifth. Add the exponents together. So now we're going to simplify. And to simplify this one, we're going to make a factor tree for 720. Mine was 72 and 10. Factors of 8 were 2 and 4. 2 is a prime number. And 4 was 2 and 2. Factors of 9 were 3 and 3. And factors of 10 were 2 and 5. So I have quite a few factors here for 72. So remember, we write them out. 2 times 2 times 2 times 2. I have 4 2's, 2 3's, and 1 5. So we're going to circle our pairs. And because that's a square root, so we circled 2 of a kind. So I have 3 groups. 2, bring out a 2 from the second group, and a 3 from the third group. And underneath should be square root of 5. Okay, so this should simplify. So we have to still simplify the radical, okay? So it's 12 square root of 5. So let's look at the radical now, okay? So I know that this 12 is going to be on the outside. I know I may have a little space, and I know that the square root, there's going to be a 5 on the inside. So looking at the indexes, remember, we take our index and we divide them. 4 divided by 2 is 2, so that divides evenly, so that all of x comes out. So x squared. 4 divided by 2, which is the index here. 5 divided by 2 doesn't work, but I could say that this is y to the fourth times y to the first. 4 divided by 2 again is y squared, and that y that cannot be divided by 2 would be left underneath. So my final answer here would be 12 x squared y squared times the square root of 5y. So remember, once you multiply, then it's all simplifying. And that's all that you have left to do is to simplify. Let's look at a dividing problem. I have the cube root of 162, y to the fifth, divided by the cube root of 3, y to the second. Now, when I'm dividing, it's the same process. We're going to divide underneath as long as the indexes are the same. Because my indexes are both 3, I'm going to combine as one fraction, 162y to the fifth in the numerator, and 3y to the second in the denominator. We're going to 162 divided by 3 is 54. Y to the fifth divided by y to the second. We subtract the exponents. 5 minus 2 is y to the third. This equals, if we take the cube root of 54, we're going to simplify 54. I did 3 and 18. 6 and 2 and 3. Now we're looking for 3 of a kind, so it's 2 times 3 times 3 times 3. My 3 of a kind is the 3's. So I bring one of those out, and I leave underneath the cube root of 2. So this is going to equal 3 cube root of 2. Now, we still have to do the variables. So remember, the 3 gets divided by the 3. It divides evenly with nothing left over. So 3 divided by 3 is 1. So this y gets pulled on the outside, y to the first. And that would be my final answer. On top of this, I want to make sure that you know that if you have something like this, and you're multiplying it, 4 square root of 2x times 5 square root of 6x squared, whenever you're multiplying it, we still, because the indexes are the same, we can still multiply the numbers out front. So 4 would just multiply to 5. And then my answer would be 20, and then whatever that square root gives me. Okay? Just to give you kind of an example, I didn't want to do this problem. It's part of your classwork today, but just to give you an example of this 31, number 31, and just kind of get you started on it. You're going to multiply 4 and 5 together to get 20. Okay, and then everything else would multiply underneath. I think it multiplies to 12x cubed, and then you would simplify it. Okay, so that still needs to be simplified, but that just gets you started with that problem. The only other thing that I wanted to talk about today is what's called rationalizing. So to rationalize the denominator, it literally means that there are no roots allowed in the denominator. So you don't want to have any kind of radicals, anything like that. So for example, a really easy way to do this is to just multiply it to the numerator. So let's say I have the square root of 5 in the denominator. I don't want a radical to have a denominator or be in the denominator, so what we do is to fix this, we multiply numerator and denominator by the square root of 5. If I do that, I'm going to multiply straight across, and I get 2 square root of 5 over the square root of 25, multiply underneath. Now you should know that the square root of 25 is just 5. So what will happen is it will cancel out and leave you without that radical. You get no roots in the denominator. Okay, so 2 square root of 5 over 5. Let's look at one more. So let's look at cube root because it's a little different. Let's say I have the cube root of 3 in the numerator over 2 times the cube root of 2x squared. So this is a problem because I don't want the cube root of in the denominator. But let's look at the factors. Okay, so looking at the factors, I have a 2, I have an x, and I have an x. Well, what would make this a perfect cube? Because the goal is to get rid of that cube root. So you want to make it a perfect cube. So I would need an additional 2, or additional 2's, and an additional x. How many 2's would I need? I would need 2 more to make it a perfect cube, to make it simplify and go away completely. So what I'm going to multiply by is not going to be just the radical. It's going to be whatever gives me a perfect cube in the denominator, so those radicals go away. In this case, it's going to be the cube root of 4x. The 4 will give me 2 2's, 2 times 2, and x will stay x in the denominator, and 3x's. And that is really, really important for just simplifying it completely. So you don't necessarily root, yes, but if it's a cube root, no. So now I'm going to multiply that to the numerator as well. It's cube root of 4x. Multiply to the numerator, and I multiply across. 3 times 4 is 12, so I have the cube root of 12x in the numerator. That cannot be simplified because there's no perfect cubes there. And then in the denominator, I have 2 cube root of 8 is 2 times 4, x cubed. What does that simplify to? Well, I have 2 times 2 times 2 times x times x times x. So I'm going to have to take out 1, 2, and 1x. So it simplifies to 2x. So the cube root of 12x over 2 times 2x. Of 12x over 2 times 2x is 4x. And that would be my final answer for rationalizing. Okay, rationalizing can be a little difficult, but just make sure that you're multiplying back in kind of what you need there. Okay? All right. That is going to be it for today. Any problems that ask you to rationalize the denominator, if you're ever left with a radical in the denominator, you must follow these steps. So I've given you an example of a square root and an example of a cube root. Hopefully you have no issues. If not, work together on it. And I hope you have a great day.